Alright, so what we're going to do now is we're going to take a look at inverse functions. So two relations are inverses of each other if and only if the relations contains the element xy whenever the other relation contains the elements yx. Okay, what does that mean? Alright, so if we were to look at two tables of points, so let's say for example, you had a table of points and your ordered pairs were 1, 3, 2, 4, 5, 7. To be an inverse, those would reverse. So your new xy coordinates, since we went from 1, 3, would switch to 3, 1. Then also 2, 4 would switch to 4, 2. And 5, 7 would switch to 7, 5. So looking at a table, that's what it means to be an inverse function. Alright, but what we're going to do right now is we're just going to focus on algebraically how to figure out if two functions are inverses of each other. So what we're going to have to do in order to do that is you switch your x and y in the equation and you solve for y. Alright, so for example, let's say I gave you the function f of x equals x plus 7. In order to find the inverse, first of all, when this says replace, so when we talk about doing the inverse, you switch your x and y. And if you remember, this f of x, that means the exact same thing as y. So we're going to say y equals x plus 7. Alright, so this is right now the function that we're working with. So we want to find the inverse. So the very first thing you're going to do now is you're going to swap them. So what that means is you're going to take this y and this x and you're going to reverse where they are. So now instead of it being y equals x plus 7, it's going to be x equals y plus 7. Alright, now I need to solve this for y, so I need to get y by itself. So right here, in order to get y by itself, I have to subtract 7 on both sides. And when I subtract 7 on both sides, I get x minus 7 equals y. Now that I have y by myself again, my inverse function is y equals x minus 7. Alright, but we want to go back to our f of x notation. So we're going to say f of x. Alright, but to be the inverse means to be to the negative 1, like if you remember inverse sine and inverse cosine. So the inverse function is x minus 7. Alright, so to kind of recap what we did is we replaced f of x with y. So we had y equals x plus 7. But then to be the inverse, my x and y have to switch. So we switched x and y. But I need to solve for y because when we look at graphing things on a coordinate plane, we've always got it as y equals. So to get y by itself, we had to subtract 7 on both sides. So on the left side, we had x minus 7. And on the right side, we just had y. So y equals x minus 7. But now we're going to go back to our f of x notation. So it's the inverse of f of x equals x minus 7. Alright, so that was a lot, so let's take a look at another example. Alright, this example is f of x equals 3x minus 4. So the very first thing is we want to take this f of x and replace it with y. So we get y equals 3x minus 4. Alright, so that's the first thing we got to do. Now what we have to do is we have to swap where our x is and where our y is. So our x and our y are going to switch places. So this is going to say x equals 3y minus 4. Alright, now again, I still have to get this y by itself. So the first thing I have to get rid of is this 4. So we're going to add 4 to both sides. So we get x plus 4 equals 3y. Alright, but now I still have to get y by itself. So that means I'm going to divide both sides by 3. So we get y equals x plus 4 over 3. So that's going to result in our final notation of the inverse of f of x. So f of x to the negative 1 equals x plus 4 over 3. And then that would be my final answer. Alright, and let's take a look at another one. Alright, so again, we've got f of x equals 2x plus 5 over 3. So the very first thing I want to do is take this f of x and replace it with a y. So we're going to say y equals 2x plus 5 over 3. Alright, now, to figure out what the inverse is going to be, I'm going to take my y, I'm going to take my x, and I'm going to swap the two. So this is going to say x equals 2y plus 5 over 3. Alright, so now this is a longer equation that I'm going to have to solve for y. very first thing I have to do is get rid of this 3, so that means I'm going to multiply by 3 on both sides, so that means I get 3x equals 2y plus 5. I need to get y by itself, so that means I have to get rid of this 5, so I'm going to do minus 5 on both sides. So I get 3x minus 5 equals 2y. I still need to get y by itself, so I'm going to divide both sides by 2. So we end up getting 3x minus 5 over 2 equals y. So our final notation is f of x to the negative 1 because the inverse function of x is equal to 3x minus 5 over 2. Let's do another example. Alright, so the first thing is, wherever I see my f of x, I'm going to replace that with a y. So I have y equals x squared minus 4. Now, second step is, again, to be the inverse, my x and my y have to switch. So I'm going to take this x, I'm going to take this y, and I'm going to switch the two. So I have x equals y squared minus 4. Now I need to solve again for y, so I need to get this y squared by itself. So I'm going to add 4 to both sides. So on the left side I have x plus 4, and on the right side equals y squared. Alright, but to get y by itself, I have to take the square root of both sides. So I end up getting y equals plus or minus, because remember, if I take the square root, it is both the positive and the negative of that number. So y equals plus or minus square root of x plus 4. But in my inverse notation, I have f of x to the negative 1 equals plus or minus x plus 4. And this would be my final answer. Alright, so now I want you to try to do the following of these three. Given f of x equals 5x minus 6, given f of x equals the square root of x minus 5, given g of x equals x minus 2 over 3, I want you to find the inverses. So again, your first step in all of these is to take that f of x and change it to a y. Then you're going to switch your x and y, and then you are going to solve to get y by itself all over again.